Hi, I'm Pakera12 and today we play with a spiral from previous tutorial trying to build a snail shell like here. This one is made out of instances, so for each point on this spiral we have either a circle, a tube or a torus with a specific rotation on XYZ and the scale in order to get this shell surface. And let's have a look on some real shells. They are all different and they all have a number of cycles required to reach to the center point, the initial radius, and most of the times the radiuses between floors they overlap. And so I draw this case, ideal case for kissing circles. And if we have an angle theta and a radius 1, we can find out the sequence of radiuses required to get to the tip in the center. And this one is a power function. Since we substitute this fraction with a constant k, let's see this in chops, and we'll not use that math, but I want to have a look to get a clue on how we need to have the radiuses, right? So let's use a constant chop, and this is k, and it's now 1. And let's imagine we have 3 cycles shell, and therefore we need 4 points. Okay, so if we have 3 here, we have 4 points, 4 samples, and we need another pattern also with 4 samples and the amplitude 3 and not sine. Instead we go for ramp, and right now we have here 0, 1, 2, 3. Let's find out a sequence where each of those k samples are powered by their indexes, and we have their indexes here. So we use function, okay, and this one, power x, y, input 1, input 2. Nothing happened now, but if we change the constant, you see the radiuses are going very fast to 0, okay? And yeah, the first radius is very big, is the one we start with, and then all the others are smaller and smaller. And we want to build something like this. We want to fake that, okay? Since we don't care about that angle, we suppose that no matter how many cycles we have, we reach the tip. So either it's 1.6 cycles, the shell will have an ending tip, okay? How we do that? Okay, let's delete this and take a constant, okay? And we need a number of points, okay? Let's go with 10, 24 and cycles, okay? And cycles we go for 4.6, okay? And now let's use a pattern. So we have a pattern in which we ask for 2 channels. First one it's y, the other one it's x, and the length of them is 1024. the cycles, we use the cycles here, and in face we say minus me dot chen index divided by 4, and this is sine and cosine. Okay, and now let's build radiuses sequence. Okay, so we start with pattern, the same number of points for the length, and this one it's ramp. Okay, and let's name this radius. Okay, and now if we use function, okay, and we take the power x input 1 exponent and we play here, yeah, the only difference is that at the bottom, at the beginning of the shell, we need to start with the radius of 1, and actually we need something like here, but inverse. So we can do this in pattern. We say -1 and 1 for the offset, and now we have something like we had before. The only thing we need to do is to specify, okay, so we have the amount of, not the amount of points, sorry about that. Here instead we go for the cycles. So since the cycles are 4.6, we will go for the mat.ceiling. Okay, and you see now for each floor we starting with a different radius. Okay, and in between, what happened if we are in between cycles? So we need the interpolation from the beginning radius of that cycles and the end radius, and therefore we need here to use a resample. Okay, and we go for time slice. Okay, and here we need the same rate, new interval, and samples. Okay, let's take the number of points, -1. Okay, and here we take absolute. Okay, and now we have the same amount of points. What if now I multiply this? So we use a mat, okay, and say jobs multiply, right? And yeah, let's put a null here, okay, and see what we got now using a job 2. And here we say take x and y for P1 and P0. So yeah, this is the spiral without a z value. Okay, and now we need the value for the z, and let's close this a little bit. Okay, and let's use something like this, the same pattern. Instead we start with the z equals 0 and we go up till z1. So here we go inverse, okay, as it was. So this one it's z, okay, and let's use now a merge here. So okay, what happened now? Okay, and this pattern, let's see this one a little bit. So the length, the length should be this one. Okay, okay, and here take also z and P2. Okay, Okay. Oh, not like that. Sorry. And now we have the spiral. Okay. And let's make the part for the instances. Okay. And so we have positions here. Let's use a select. Okay. And take this. And let's rename this from XYZ into TX, TY, TZ. Okay. And here we'll use an object chop in order to find the rotations. Okay, for this one we need also a feedback, so we use a feedback and then we put those two here, and in the object chop we need the measurements and not positions, instead the bearing. Okay, and nothing happened now. Let's go here and how we make this move a little bit, right? So we know that if we change the face, the spiral, it looks like it's moving, and now the face here, it's taken by this expression, but we actually can say plus ABS time dot seconds divided by 30. Okay, and now we have motion here, and also the object chop, it seems it's working on some rotations, right? We need here in channel to say start end, and let's specify the end. The end would be this -1. Okay, so now we have the rotations here. I like to use a merge. Okay, and now we have positions and rotations. Okay, and let's use a null here. Okay, and now for instancing, what if we take a circle? So we take a circle, and let's use open arc, and now a geometry in which we go for instancing, and we use this null 2. Okay, from which we take TX, TY, TZ, and also RX, RY, RZ. Okay, we have something, but right now we don't have a scale, something to make each circle smaller as it goes closer to the center tip. Okay, but what if we use this radius here? So let's take that in a select. Okay, so select chop, resample. Okay, just a second to open the door for my cat, just a second. Okay, I'm back, and yeah, so we take this radius, right? And we plug this in here, and now we use that here for the scale. So we go with the radius for all XYZ scale. Okay, and let's see that geometry much better. What we have now. Okay, let's make this a little bit smaller. So right now we have a shell let's use a material, a constant one. Okay. But obviously the height, it's wrong. So if we take a look here, we use something which is linear, okay? And instead of this, there is some relation between the sequence of radiuses and the y positions of their centers for the circles. And we don't go into that, but if we take this resample in a select, okay, and we use a math here, okay, and we go from 0 to 1, we change from 1 to 0, okay, and yeah, let's rename that Z and use that. Okay, okay, a little bit better, but what we need now is what if we want to increase the height, not stop when it reach 1, you see? So if we take a look again on this drawing here, the height of the shell is sum of all the radiuses multiplied by 2 minus first radius and minus last radius, multiplied then by a cosine of this angle. So actually it's a sum of the radiuses, and let's do that, okay? Here we'll out of this function, let's select this. We have 5 radiuses, right? What if we want to find out the sum of them first? So we use analyze, okay, the sum is 1.5, so obviously we are much higher than 1, right? So here should be something else instead. Let's use a null. Okay, now we can take this value here, and this one would be also Z. Okay, so now it's Y. Let's say Y. Okay, and let's take this here in this math. Okay, now you notice we have a much nicer tip, and let's stop for a second and try to make this more visible, because right now it's only lines. So instead of circle here, let's use a tube. Okay, so we have a tube, right, and we need this to be on z-axis, and height it's 0.1, and let's try now. Okay, and instead of constant, let's use a Phong. Okay, now it's looking much better now. Okay, and we only put here the sum. Actually it's not only the sum, so let's make another analyze. So Ctrl C, Ctrl V. I want to take the maximum. Okay, also I want to take the minimum, and this minimum. Okay, it's 0. Obviously we have couple of cycles and we reach the center tip. Anyway, first one and second one will be subtracted by the by this double of the sum. So I can say like I use a math here. Okay, let's imagine we didn't have 0 for the last one, and here it's add, and this value here I will use it here in another math job where I say, okay, multiply by 2 and then subtract this. Okay, and minus. Okay, and now it's much better. And what else we can do to little adjustment? We can use here a math. Since in my drawings, right, is this sum multiplied by cosine of this angle. So if we use this multiply here and we decrease here, yeah, we can change the shape of the shell. Yeah, and yeah, let's see how we color this. Okay, it's looking nice. And for the color, I want to have something with the same amount of samples. So what if I use a noise top? Okay, and for the resolution I take this value here and 1. Okay, and okay, let's make this 32 RGBA and color. Okay, and now a null, and now I can drop this null since it has the same amount of samples, the resolution, and I drop it here. Okay, I'm using the experimental version, so okay, now I take RGB, and I have colors on my shell. Okay, now you can play with this noise to get what type of colors you want. Okay, so you either go with this dense colors, or I wonder how it will look some noise taken not out of this surface, instead taken out of the points on a spiral. So here I have the points. If I take the chop 2 and RGB, okay, now I can use that here. And right now it's flickering since it's moving too fast. But what if I increase here the period with, I don't know, 33 maybe, I don't know, 20. And here we go with 0.2, 0.2. Okay, yeah, let's play with that. Okay, it's looking good for me. Maybe a little level after, and the brightness, increase the brightness by 1.25 maybe. Okay, now we get a much nicer shell, and now we can change those value. If instead we want more cycles, we can add the cycles, and the shell will stay very nice. And also the number of points, if we use a higher amount, it will go smooth. It's a very nice way of dealing with instances. Okay, and let's try another another type of geometry. Here would be torus. So if I take a torus, okay, and let's have it on z-axis, and radius it's 1. First one, let's say 0.9 and 0.1. Okay, and now let's use this here, and you see now we have much better surface in terms of mesh. It's not quite mesh, but you can use now shadows and PBR materials and so on. Okay, what I want to show you, it's something else. And what if instead of using those rotations, we make some little mistakes. Let's see what happened if I use RZ here instead. So you notice the shell will change the shape in, I would say, very intricate way. And if I take RZ for all of them, yeah, it's the same, very little change, since on Y we have a different type of rotation. You can see it here. Okay, and yeah, this is my tutorial. I hope you like it, and subscribe if you did. Hit the like button, or you can follow me on Patreon. There I'll have a couple of more exclusive tutorials for my patrons, and which I thank them so much for supporting me. And yeah, I wish you all a Merry Christmas, and see you in the next one. Bye.